Hi everyone. So today we have this interesting release from Microsoft. So they recently released Phi-3, their new 3.8 billion parameter language model. It's exciting. It's being covered everywhere and all over the news. It's blowing up on Twitter as well. And so what I wanted to do in this video is I wanted to go through the details. There's a technical report of this release. I have the TLDR here on my Twitter account. But I will go through some of the details in the paper and also maybe take some minutes to try it out ourselves on a few tasks. You can see that Microsoft is really interested in building these very effective and efficient small language models. There is many explanations to that, but I believe that the approach of training these small language models and kind of building up on the insights and knowledge that you're getting from training smaller language models rapidly, I think it's an interesting approach. Not a lot of companies are taking that approach for training these models, but I've been following Microsoft for the last, I don't know, year or so. And I like this initiative of Phi models because of, again, trying to incorporate insights, and you will see that there's a lot of focus on data quality for this particular model, which is kind of interesting. It's very different, I think, from other companies, but I believe other companies as well that are focusing on really large models also can gain a lot from this type of release. The main model here is the 3.8 billion parameter model called Phi-3 Mini, and it's trained on 3.3 trillion tokens, I believe, and it rivals Mixtral 8x7b and the GPT 3.5, right? So this is the mixture of expert models, and then this is also the GPT 3.5 model. So that's amazing that a small model like this can already compete with some of the top small performing models. So it has a default context length of 4K. And then it can be extended also. Actually, they did that and they reported in their paper. It's a 128K and it's called Phi Mini 128K, and that's the context length. Right, so that's the extended version. And one of the main things of this release is the focus on heavily filtered web data and synthetic data. So it's a combination of the two, focusing on quality and training these models on what is very filtered data, right? I think that's an interesting approach, and you can see from the results that there's something there to learn from, and there's a lot of insights in this technical report that we can borrow as a community. I also report results for the 7B and 14B, although these haven't been released. They are 7B and 14B, so they're Phi-3 small and Phi-3 medium, and they've been trained on 4.8 trillion tokens. So you can see that they're scaling up these models as well. There's a lot of interest for that as well, apparently, from this team. So they started with the smaller models and now scaling all the way up. Will be interesting as well to see what are the other sizes that they're planning to release. If they're going to release these ones as well, it's going to be interesting to see in the future. So there's a lot of excitement for that. The Phi-3 Mini achieves 69% on MMLU. I know MMLU is one of the common benchmarks, right? Measures like reasoning, math reasoning, and so forth. But there's a lot of interest in performance for this particular benchmark. So I reported that here. And you can see that when they scale these models, so how the performance goes up. We will touch on that in a bit when we touch on the technical report. This is just the summary of it. Yeah, so one of the claims that I thought was interesting in the paper is that, they report that because the model size is limited, it has less capacities to store factual knowledge. I don't think this is surprising. I think this is what many papers, people that are doing large language models are reporting. But it makes it weaker for certain tasks, right? So maybe tasks that are knowledge intensive or so on. But we know that there is like these RAG systems as well that can be combined, right? You can combine different external tools and external databases, whatever, knowledge base, whatever that may be, to account for, to kind of bridge that gap, right? The knowledge gap. If you track some of the, like my thoughts around large language models, I usually talk about small language models and the power of these and why we need to do more work around this. And so I get excited when I see these smaller models that they can compete and sometimes even outperform these bigger models. Just for the fact that these models are more accessible to more people and more people can experiment with them and try to figure out ways on how we can improve them whether it be on performance, whether it be on the context length, whether it be on use cases, safety, whatever that may be. So it's a really good win for the research community as well. I mentioned here, we are waiting for Llama 3 400B, right? It might be the most powerful model eventually, but we also cannot ignore this particular model, right? And potentially what it can achieve. So you can imagine like a Phi-7TB parameter language model. We don't know what's possible here, but we'll look at the results and kind of take a look and decide for ourselves, what could be possible here. So let's look at the technical report. So we have technical report. We have some details here. I've summarized basically that in my tweet, and then I'll go through some more specific details here. There's a lot of really interesting references here. Basically, it's just trying to put together all the insights and lessons learned from the scaling laws all the way to how we filter data and so on, right? And the type of tests that we're doing also with these models and how we measure performance and capabilities. So there's not going to be a lot new in this paper, but I think the decisions for architecture, decisions for how the data was created and so on, I think it's really still a lot that we can gain from this particular paper. So the main model here that was announced is the Phi-3 mini, which is a 3.8 parameters model trained on 3.3 trillion tokens. And it's obviously a larger and more advanced version of the dataset used in Phi-2, okay? And I think, if you look at the paper here, right, it says a highly capable language model locally on your phone. So they're targeting on device. I guess it's really interesting, right, because you can potentially run a model like this on your phone. And I think that's interesting for a lot of people. But just the fact that we have a very powerful model, right, that we can use even locally on our computers, that's already really exciting. So regardless if they're really targeting something else with these models, I think it's still generally very exciting. All right, so there's some technical specifications. Now, I see a few things here of interest. So we have the context length 4K. That's the default, right, for Phi-3 Mini. And they use this approach, which is long rope. I keep mentioning, right, they're using insights that, this is all about research, right? And why the research community really matters, that they're using insights to try to extend, in this case, the context length to 128K. Extending context length is also very challenging. Usually when you extend context length, you lose capability, you lose performance. But you can see that they have done that. And I'm not sure if they have results, but we'll take a look below, see if there's any results for this particular model and see how it's performing on the different benchmarks. They do report that if your Phi-3 Mini we know that Llama 3 was released recently, right? I don't think there's a lot of mention of Llama 3 here. There is mentions of Llama 2. Keep in mind the Llama 3 was last week, and just in a couple of days we have this model here. And this one is a tokenizer of 32,064. I believe it's the same one that was used for Llama 2, right? It's the same tokenizer. And I know this because when I did my Llama 3 video, I mentioned this, that they used a different tokenizer than for Llama 3, but they kept saying that they improved the tokenizer that they were using and so on, right? They did use a completely different one with a bigger vocabulary. All right, so the model is here. We have it has a 3072 hidden dimension, okay, and then 32 heads and 32 layers and so forth, right? It's trained on bfloat 16 for a total of 3.3 trillion tokens. And then we can see here that the Phi-3 small model, which is a 7 billion parameter model, leverages a tick token tokenizer and with a vocabulary, right? So you can see the size of the vocabulary here. And you can see that they're kind of saying exactly why they made the decision, because they want for better multilingual tokenization, right? They use a bigger one, which has a default context length of 8K. And this one follows the standard decoder architecture of a 7B model class, having 32 layers, hidden size of 4096. And they mentioned something about the KV here, cache footprint. Obviously, we want these models to be efficient as well. And so what they have done here is they leverage group core attention. This is something that Llama 3 reports to leverage as well, with 4 queries sharing 1 key. And then the small model uses alternative layers of dense attention and novel black sparse attention. That's interesting, I think, this combination of attention mechanisms to further optimize the KB cache savings while maintaining long context retrieval performance. So again, I keep saying that when you do long context retrieval, usually you kind of you miss performance maybe, or you're making these models less efficient. So I think these decisions are to cater for that. And then here they report an additional 10% multilingual data was also used for the smaller range, so additional data. Okay, so this is the on-device part. It says, thanks to its small size, Phi-3 Mini can be quantized to 4 bits so that it only occupies 1.8 gigabyte of memory, right? So I'm not really into the on-device stuff, but I know that a lot of developers are playing around with it. So quantizing these models efficiently and effectively is also kind of interesting, and a lot of members in the community are playing around with these models this way. So that'll be interesting to see what people can come up with in terms of these small models. Training methodology, right? This I think is the most important part of the paper. Again, this is nothing new with this family of models. So from I think the beginning, with the textbooks are all you need paper, they showed a lot of emphasis on training these models with high quality training data, right, to improve the performance of these small models. And so, it's a deviation from the standard scaling laws, essentially. And so you can see here, they mention the data optimal regime and how they have, they're unlike prior works that train language models on the compute optimal regime. You can read paper here. Or overtrained regime, they are focusing on the data optimal regime, right, for small models. And that makes a lot of sense. They filter web data to contain correct level of knowledge and keep more web pages that could potentially improve the reasoning ability for models. So instead of focusing on facts and so on, they are trying to target to make this model better at reasoning, and then potentially mix this with a search engine or something like that to improve factual knowledge as well. So leave more room for reasoning, right? We need these models, smaller models, to be great at reasoning, and then we can potentially combine them with external tools like we're doing with all these agents and so on. So here is just some pictures here on the 4-bit quantized by Stream running on an iPhone. For those of you that are interested. Now, this chart is really interesting. Now, I look at this, and the way I interpret this is that they're using this data optimal scaling law, right? And they have this Llama 2 model here. You can see how the error rate for MMLU decreases. And very interesting that for these Phi models, which is, I believe they're using the Phi-3 Mini as comparison. So this one is Phi 1.5, Phi 2, Phi 3 Mini, and then Phi 3 Small versus the Llama 2 family of models, which is 7B, 13B, 34B, 70B, right? You can see how this model, how rapidly it goes down, right? The error rate. And that's fascinating, right? Even though these are a smaller set of models compared to this set of models, you can see the gains that you're getting, right? You're obviously reducing the error rate in the MMLU, which is, I think, a tough benchmark already, assuming there's no data contamination and so on with these tests and experiments. That's really awesome to see. I mean, I'm very excited to see how the 14B and then potentially 30B and so on. I do expect that Microsoft is going to do that, release these smaller models. I would have loved to see, for instance, the 30B from Llama 3 or Llama 2, but we didn't see that. But I think we're going to get it with this particular family of models. Right, there's more about post-training. I'm not going to go through all of that. More results about academic. The last thing I want to touch on here is this benchmark, which everyone really cares about. When you're doing model selection, obviously you want to see that you want to use the more capable models, especially for some of these benchmarks. You can see for GSM-8K, math reasoning or math word problem solving. You can see how this model performs. So the Phi-3 Mini 3.8B, 82.5, 88.9 for the 7B, and how it compares with something like Llama 3 and Mixtral. You can see the results here. So it even outperforms GPT 3.5, this particular version. Right, so we have the Phi-3 medium results as well, even better, with more significant results here as well. Okay, so you have all the comparisons here. It's really amazing, right? You can see that even the smaller version of that is already competing or outperforming Llama 3 in shock version 8P model. So that's, and it's less, right? It's half the size of this particular model. So you can see you can get a lot from focusing on data quality. Now, there's an example here. This is the one I want to try. Now, you can download the models here. If you go to Hugging Face, there is more details, technical details as well, like the chat format, if you're going to use it via the APIs or the transformer library. There's all those details here. And then you also have more details about benchmarks, the hardware that was used, and so on, class platform support, right? What's supported there, the license and so forth. It's an MIT license. So in this demo, what I want to do is I want to try out the Phi-3 Mini 4K instruct model from Microsoft, and you can try it using the Hugging chat. So you go to models, and you can see that you can select the model here. So I actually want to test the same query here. So plan me a one-day trip to Skagway, Alaska. I think I said that correctly. I'm not sure. And I want to do one with search on and one without search on to see the difference in the results, right? So this one looks more detailed compared to this one. So, giving it access to that knowledge base is really kind of key, apparently, with this type of models. But what we're going to be focusing on is trying to assess how it formats it, right? How it's reasoning about the actual problem here, the actual task, and then how it puts together all that information, right? We know that these models are focusing on reasoning capabilities as opposed to factual knowledge, but the search engines should account for factual gaps that it has. So what I'm going to do is I'm going to copy the same one, plan me a one-day trip. Then I'm going to try without search first. Plan me a one-day trip to, actually, I'm going to say Belize. I'm from Belize, so it'll be interesting to see, and I will more or less know if it's accurate if I say Belize because I'm from here. Okay, let me try that. All right, so it gives us an introduction. Okay, I did not expect that. Okay, this is an introduction to Belize. That's totally okay, but I can see that it's right. It's nice format. It looks like it's telling me, it's giving me an itinerary. It's breaking down by timestamps as well. Okay, breakfast at La Cocina, Belize City walking tour, then lunch at the Belizean Grill, then snorkeling at Half Moon Cay National Park. The timings are great here. Visit the Belize Zoo at 4 p.m., then dinner at the Belizean Grill. So that's the recommendation here. Then sunset cruise on the Belize River, and then return to your accommodation. So it looks like this is one-day trip, right, in Belize. And then it gives you this kind of note at the bottom as well. So it looks good. I mean, there's not a lot of details. I could see that they're making suggestions even about the food and so on, right? And trying some traditional dish. That looks great. And try the famous Belikin beer and so forth. But let me see if I turn search web, if it makes any difference. This already looks great, by the way. So I'm really interested to see if it improves if I use the search web on. So I'm going to just do a new chat. And then I'm going to leave the search web on. See what's the difference. Okay. So now it's going to look at the web, try to look for links or blogs or something like that, and it's going to try to provide potential an itinerary as well. So here we have it. Okay. You can see it gets more detailed, right? This is something that you see in the example in the paper, right? It gives you, okay, like the book in the morning, and then afternoon, evening, and so on. And then it tells you the dinner. So you can see it's more structured when it's leveraging, external data. But I think the format is good. And I think the amount of information that we have here, maybe there is some additional information, which is, I'm going to say, like the specific category here. This labeling here is really nice. It's categorization. So I really like that. I'm not sure if that's exactly because of us using web search. It could be. I need to do a couple more tests. So I'll be testing these models more and reporting more on what are the capabilities. But I think this is great. And actually, this is a very popular blogger, Taco Girl, and blogs a lot about Belize. So there's a lot of information about Belize, where to go and which spots to pick to eat and so on, how to have a great time in Belize. So I think that's a great reference here. That's good. Okay, so that'll be it. I just kind of slightly tested it. I'm going to do more tests on it in another video potentially. Potentially also I might include some more details on how to use these models better in our prompting guide as well. So keep up with that. If you don't know about our prompting guide, you can check it out. Our prompting guide is here, and we usually talk about these models. I haven't added Phi-3 yet, but you can see that this is all our models here, and we provide tips on how to use these models, how to prompt them, and so on. So potentially we will do that in the next few days as well. That'll be it for this one. Also, please feel free to leave a like and follow the channel. That will let me know if you are enjoying these videos. If you want to see more of these videos, that'll be helpful. So thank you and have a nice day.